So this is problem number 3 off of Webassign, and it says the following. Let's consider the following scenario. Let there be an event C, and the probability of event C occurring is 0.2. And let there be an event D such that the probability of event D is 0.3. And then we get another event, the combination P of C given D. So event C given event D, its probability is 0.4. Well, we're asked, first of all, in this problem, let's find the probability of C and D occurring. Well, okay, let's go to our calculation here. We have our rule on the right. The probability of C and D occurring, according to this rule, should be the same as the probability of event C times the probability of event C given D has occurred. So we're going to make the multiplication of 0.2 times the probability of C given D, that's 0.4. Well, when we multiply those, what do we get? We get 0.08. So that's going to be our first probability answer here. So let's go to our problem, 0.08. Okay. Are C and D mutually exclusive? Well, probably C and D are not mutually exclusive right here. I think we should say that there's not enough information really to give us that well, mutually exclusive because they have different probabilities. No, not necessarily. Are they mutually exclusive because PC and plus P of D does not equal 1? Well, that's not necessarily true, right? I mean, even though they add up to be 0.5, are the probabilities C and D not equal to 0 or not mutually exclusive? Well, let's say they're not mutually exclusive because C and D does not equal 0. Are they independent events? Well, in this case, the events are not independent. And the reason why is that the probability of C given D is not the same as probability of C, right? So we can exclude that one. So let's go to the last one. What about this probability of D given C? Now, that's an interesting one. Let me talk about how we might handle that, right? And the way to think about this is that, what could we say? Well, it turns out that these two events right here are equal, right? The probability of A and B is equal to the probability of B and A. So the probability of A and B occurring is the same in both instances. And we've said, well, that's 0.008. Right? So in both cases, right, no matter which way we arrange it, the probability of A times the probability of A given B, right, would be the same whether we say the probability of A and B or the probability of B and A, right? These two guys are equal to each other. So in fact, we want the probability, we want to find the probability of D given C. And the way that would work out is if we said, well, let's take the probability of event D and say that's the probability, gotta get my pen in the right place here, the probability of C and D occurring. Well, we already know the first one, it's 0.08. And we also know what the probability of D is, it's 0.3. So whatever the probability of D given C is, we're going to find it by doing a little bit of division. Divide by 0.3. So we're going to divide by 0.3. All right. And let's go ahead. Let me get out my calculator right here. I'm going to get my handy-dandy calculator. And what does it say? Well, my probability calculator here says that if I divide 0.08 by 0.3, I'm going to get 2.667 repeating. So 0.26667, right? So we get 0.2666, and this just repeats, equals probability of D given C. And if we go to Webassign, it says, let's give that number. We're going to enter that number. And it doesn't tell us how we want to do it, but we could enter our number here as 0.2. What did we say? It was 0.266667 repeating. So 0.2667. We'll round there. Well, there it is. That's our answers right there for problem number 3.